Hey, welcome back for 6.7 notes. These notes are called the natural logarithm, but I'll be honest, there's a couple other random things. These notes are probably going to be a little longer than most, just because I want to make sure that I explain it all thoroughly. So, the first thing we're actually going to talk about is called compound interest. And this is the formula for compound interest. It's similar to exponential growth and decay, but this represents how banks and other institutions actually calculate interest rates. So, first we have the principal amount P. This is how much it starts with. A is the final amount. So, these two things in front, the capital letters, those are your amounts. This is the final, this is the initial. That's what principal means, is the initial amount. I'm just letting you know that because we don't really use the word principal a lot other than to describe Mr. Abel and people like him. Uh, then you have the R. That stands for the interest rate. Just remember that when we do a rate inside of a formula, we want it to be in decimal form. What that means is, for example, on this one, it's 8%. That means that our R value is going to be 0.08. You have to divide this by 100 to get this. Okay. Then you have the number of times per year, and this is the part where the word compound comes into play. Compound means it's going to do it this many times per year. So if this says something like quarterly, a quarter is a fourth, so that's 4 times a year. If it said something like monthly, that's 12 times a year. Daily would be 365 days a year. Then you have time. T is time, usually in years. That part's not too difficult. We have actually done rate and time before, so those parts aren't new. And basically what we're going to be doing is setting up the equation. So A is the final amount. That's what it is asking us for. How much is in the account after 10 years? So we want to find A. The first thing we need is P. How much money did we start with? That's this 2,500 up here. Then you put the rate, 0.08, on the top of this fraction. And on the bottom, you put how many times per year. It says monthly, so that's going to be 12. In the parentheses, and then in the exponent, you take the same number, the 12, and multiply it by the number of years, which is t. That's 10. And the glorious thing about this is you're pretty much just typing it in your calculator from here. 2,500, 1 plus 0.08 divided by 12. And then we're going to hit the exponent button. And I'm going to make this suggestion for those of you at home. If you don't have a calculator that looks like this, you're going to want to do 12 times 10 on your own really quick in your head. 12 times 10, 120. So that it doesn't do the order of operations incorrectly. Everything else on here is probably going to be fine. That part just gets a little tricky. So after 10 years, this account has $5,549.10. Which isn't a bad interest. You've done a little bit more than double your money in that case. And then we're going to move down to example 2. And I'm going to warn you that example 2 has a lot of ones. Our principal amount is $1. Our rate is 1 because it's 100%. Our time is 1. So pretty much everything is 1 except n. This is going to be n equals 100, n equals 1,000, and n equals 10,000. And I'm going to set all of these up and then I'll talk about them for a second. So P goes in front. 1 plus R is 1 over N is 100 to the power of 100 times T, which is 1 year. So pretty much everything is a 1 except for these N values. Then coming over here, all I have to change about the problem is that instead of 100, I need to put 1,000. Just make sure you change it in both spots. And then on the last one, we're going to change it to 10,000. And I'll give you a second to make sure you have those set up too. It's just easier to see them all first. So we're just changing this number down here and here. Go ahead and pause the video if you need an extra second to write that down. And I'm going to type this in. Okay, that's with the 100. Now let's try the 1,000. And the 10,000. Oops. Hang on, I want these to be in order. But I made a mistake. There we go. So this is the 100, this is the 1,000, and this is the 10,000. Now you might be like, Mrs. McFadden, why are we doing so many of these zeros? Because I want to show you what happens as the number of times per year starts getting really high. Like 10,000 times a year is a lot. And what happens is we have 2.70, we're going to turn this into a 5. Then we have 2.717, and then we have 2.718. So you'll realize that these are all about the same number because, first of all, we only invested $1, which isn't going to change your amount very much. But what's happening is as these number of times per year gets really high, these numbers right here start getting close to something called E. And E is 2.718, by the way. E is called a number, special number called Euler's number. It is represented by the letter E for Euler, even though I know that's not what it sounds like. E is kind of like pi. So pi is a decimal that never ends, and it is approximately 2.718. And the whole point of doing this is to kind of show you what happens as we find something called continuous interest, which, by the way, is what this word right here should say. And what continuous interest means is that something is gaining interest every second of every minute, of every hour, of every day, of every year. So it's just like constantly gaining interest. And that's why we were trying to get N to be a really high number, because that's actually infinite times per year. So as we start getting into like 10,000, maybe a million, we're pretty much basically at infinity as far as guessing purposes go. So that's why as we got a higher and higher number, we basically found out what E was. So this letter E is a number that we use to find something called continuous interest. And there is a new formula for it. It's right here. And it looks kind of like the other one, except for this part right here is replacing the 1 plus r over n to the power of n. So that part isn't here anymore like it was up here. So this is actually a simpler formula. A lot of people call it PERT, because that's what these 4 letters over here spell. And basically, instead of doing all of this complicated nonsense, you just use E. Because all of this turns into that if you have just the ones and stuff. So that's just kind of the value of all of this, no matter what initial investment you have or what percent you have. So what we're going to do is find out how much money is in same amount to start with that we did on example 1. So 2,500 is still what we're starting with. But instead of going to these, we just go to E, to the power of r, which is still 0.08 or 0.08, times the number of years. So it's a little bit shorter of a formula. This is the one you use if it says continuously, because we don't know how many times per year continuously is because it's infinite. But we do know that as it becomes infinite, it approaches this number right here. So that's really what's going on right there. Okay, what's up? Yes. There you go. You can take the whole thing. Mm-hmm. And all calculators have a button for E somewhere. It's right here on mine, so I have to hit second E. I want you to try and find the button that means E because it's going to change your number just slightly. Okay. If you use 2.718 instead, see how it just changes the number of cents? So this isn't as exact of a number. We've kind of rounded. So that's why this number is lower than this number. So if you want your full interest, use E instead of 2.718. The same way we would hope that our bank would. $5,563.85. Now let's compare. It was 10 years in both examples 1 and 3. The only difference was instead of monthly, we did continuously. So this one is about $5,549. This one is about $5,563. So since continuously happens more often, it gives you more money. And then we have example 4. An account has this much after being compounded. That means that this is your A value or your final amount. So that part's going to go on the left. And we don't know how much it started with. That is the question it's asking us. So P equals question mark right now. But we do know that this is being, sorry, you do not need that parentheses, compounded continuously. So that's where we put the E next instead of the parentheses. And then we're going to go with the rate times time as the exponent. 4% times 5 years. Okay, now this right here is just a number. It is being multiplied by P. We've done something kind of similar to this before. So what we need to do is divide by E to the power of, and I'm actually going to do 0.04 times 5 really quick, just to make my problem a little bit simpler on both sides. So that these cross out, and you just have this. $2,564.95 divided by E to the power of 0.2. And we're going to go ahead and just call this $2,100 because this doesn't round this to 1 cent, so it's exactly 2,100 even. Okay, so if it gives you the final instead of the initial like this, you're just going to find out what this is, or kind of plug in the numbers here, divide by this to the other side. But notice how I didn't find out what decimal this was, because I don't want to round, guys. I want to do this all in one step, because if we round in the middle of a problem, it throws our answer off a little bit. Stay tuned to the next video for the back side of